So, welcome to the AWS Summit in Los Angeles. My name is Aaron Hunter. I'm a Principal Developer Advocate with the AWS Developer Experience team. I'm joined with two of my really good friends, Robert and Jasty. And let's go ahead and get started. Robert, what are we doing here today?
Well,
we got a clicker.
Oh, we got a clicker.
We got a clicker.
Now, which one do I click?
Do you want me to do the clicker?
I
think it's the arrows.
Okay. There we go. Cool. So we're going to talk about a tool that's we call TC that simplifies the issues that you might face when you're doing serverless. We found that doing serverless infrastructure, all the tools that we had, like Terraform and CloudFormation, didn't really match the kind of speed and iterations that you want to do with serverless. And they didn't really add to much of the simplifying the complexity that you might face. So
I hear everyone asking it already, Robert. What is TC?
So TC is an open source description language that treats the infrastructure as what we call cloud functors. So these are namespaced, sandboxed, and they version topology. So instead of dealing with individual elements, you're going to deal with a collection of components that you can compose.
So funky elements turn into cloud functors.
Yes.
Got it.
So you can define how they work together logically, and the tool will actually render the infrastructure and figure out many of the things that you would have to do manually in a regular IAC. So it'll figure out all the IAM roles and because it knows all the connections between all your elements.
I'm a huge fan of tables and forms and stuff, so this one makes me really happy. Attribute, traditional IAC, like the traditional boring stuff, and now you have TC, the topology composer. So really cool because, as Robert explained, it's gonna take these like funky things and turn it more into like a composed cloud functor. So you have your mental model, your analogy of security and architecture, but I'm gonna let the expert talk more about that.
Yeah, so basically, with a regular IAC, you'd be thinking more about like just the lambdas and the IAM roles and the events and things. Here you deal more with a component that would contain those things, and you define the relationships between them. And that, as I mentioned, one of the big factors is that it'll figure out all the roles and policies that you need.
One of the big factor of the functor.
Yes.
Okay.
And instead of like flat monolithic stacks of resources, you're again dealing with kind of a tree of these components. So we still see that there's a role potentially for traditional IACs to kind of lay the foundation of kind of all the static elements that you might have. So we call that the bones of the system. So things like VPCs, creating a database or creating an API gateway. But then TC can you can describe the relationships between all these things, and that lets you create this dynamic infrastructure. So, for instance, like you'll be able to just update your lambdas as needed instead of going through a whole convergence of a CloudFormation or a Terraform. And this works completely by there is no state except for the state of your environment. The other nice thing is everything can be namespaced, so that you do one definition of your infrastructure, of your architecture, and then it can render all the different environments dynamically. So it can create your QA, your staging, whatever, or even just dev sandboxes from the same definition of your architecture.
Can I ask a question for the audience? If you go back one slide real quick, it's a 5-second question. The bones, Terraform, quick show of hands. Who currently uses Terraform or any kind of IAC? 1, 2, 3, 4, 5, 6, about 7 people. So this will make it easier for you if you want to explore it.
Yeah, and again, this is focused on serverless. That's the current, really target. Then we've also found this pattern of what I call kind of a recursive orchestration pattern. So we use step functions as orchestrators, and they can drive the all the different things, primarily lambdas, but it could also you can do pretty much any service in AWS from that. And one of the nice features of this architecture is that any error state that comes from the leaves can bubble right up to the orchestrator, and you can have a common error handling kind of structure. So that's kind of the basic nice feature there. And as we mentioned, since it knows the connections between all the elements, it can know what each lambda or each step function needs for roles and permissions.
I see here it says no manual wildcards. So are they automatic wildcards then?
Yes.
Okay.
No, so it'll scope the resources very tightly, automatically, and that's been a really big advantage. And we're sort of the first generation of TC has been a CLI that kind of did the whole thing. So you just had the definitions, which we'll show in a moment, and then it then renders it, as I said. But we're now going to separate that composition into something that will have a total static data structure that can then render to any kind of, you can build any kind of backend. So we could even build something to generate Terraform or CDK or something else. And then we also have a companion app called Praxis, which is a UI component that's more for managing deployments. So you can actually have a manifest of your deployment of your entire system, all versioned. You can specify which version of each component, and then say deploy that to staging or deploy that to QA or production. So I think
I see it coming soon. Mentat.
Yes.
Is that it?
Mentat is
Okay.
this separation where we have the definition can come in and produce this data structure that can then be used by any kind of custom or standard backend.
Got it.
So that's coming soon.
I see Mentat and I think Meerkat. That should be the logo maybe.
It was more from Dune.
Speaking of seeing stuff, I think you have a demo recorded for us, so kind of walk through.
Do you know how I started here? Or it's built in? Okay.
So there's audio in this, but you're going to walk us through it so that way we can understand what's happening, yeah?
Yeah, so this kind of shows what we're doing. We're going to post a message. It's going to go to function F1. It's going to publish it to a AppSync channel, and that's going to show up in the web app, and it kind of just will go through that. This is the actual definition so this is what you would write to define the system that we're going to show. So again, we have the routes for the API gateway, the events for the event bridge, the function definitions, and we're saying this event will talk to this function will call F2 and send to channel C1. So you can see how it's kind of wired up in this YAML file. And then this is the actual web app will be built, put into dist, and sent up to S3 and CloudFormation distribution. And we're just specifying the bucket it will send to. So here's the TC command. We're going to say create, and this is the sandbox name. So everything will be namespaced by this and be sent to this environment. So that's the account name, effectively. And then it will now do all the stuff with figuring out the roles. And yes, so these are all the roles for the different functions. Just, creating the function, and you can see over here, it knows how to build things, has conventions, or you can override the builds. Creating the API routes, and now it's building the application in this case is just index.html, but it's pushing it up to the S3 bucket, creating the distribution, the CloudFront distribution. That would have normally taken about 5 minutes just for the CloudFront distribution. It's also organized, so the directory structure is how you can create the hierarchy. So in this case, we just have one level of hierarchy. And this kind of, you can visualize it. So that was a TC command to visualize what you just created. So I think the video doesn't really wait for it, but
And Robert, you have a full version of this video somewhere, yeah?
Yeah, we'll be posting the full video, and we have some articles and stuff like that at the GitHub. You'll see at the end, but it's basically tc-functors on GitHub. This is the URL for the distribution. So we copy that, and we'll bring up a Chrome. That should show that. Post that in. So this doesn't do very much. Basically, we're going to say a message and post it. We're not going to see the message, but we'll see those updates to the progress bar that was each function is producing that, sending it through an AppSync event. And this is the templating. So you can put mustache templates into anything really. In this case, it's the index.html. And when you do the create, it will insert all the appropriate things for that environment. So the final index.html will have that all properly rendered. But you could also do that in your functions, in your function code, stuff like that. So that's how we get the ability to easily support these sandboxed environments. Can't believe I'm talking faster than the original video. So that, I think we're also going to see that, this is the rendered one. So all those things are now filled in. So now we're going to show that you can sort of iteratively develop. In this case, we're just going to add the domains, and this will actually create all the ACM certificates and set up the Route 53. Assuming you already set the base domain, it will update. So this simple command. So you can see you can operate on any subpart of the functor, of the component. In this case, we're just updating pages domains. But you can do that, like you can update just functions or your step function or anything like that. And so now that the magic of video editing, it's using the new domain name.
Nice. And you have a full video, and you can also find more where? On the dev.to on your blog. And
we have a series going on this, and then this repo is where we have all the stuff that's either here or coming, plus pointers to the documentation and other videos and articles.
Well, thank you so much for showing us about taking funky functions and turning them into cloud functors.
Yes.
All right, round of applause for Robert. Thank you.
Thank you.